Hi everyone. Today we are going to discuss aggressive curves. This question is like one of the toughest questions in binary search. If you want to learn binary search, this is one of the problem which you should never miss in the binary search. So let us see what this question states. You are given an array of consisting of n integers which denote the position of a star. You are given an integer k which denotes the number of aggressive curves. You are given the task of assigning stalls of k curves such that minimum distance between any two of them is the maximum possible. The first line, okay, they had given this test case. Let us see what this question states here. They had given 3 and the output is 3. So this question states is we have to place the k number of cows in such a manner in the given stalls in such a manner such that the distance between them should be the maximum possible. What it states is, for example, if we put our first cow in this index, and if we put our second curve in this index and the third curve in this index, if we see the difference between them, that is 1 and 4, what is the distance between them? That is 3. And 4 and 8, the distance between is 4. So 3 and 4. If we take any other possibilities, now possibilities will be that is greater than 3 and 4. So 3 should be the minimum possible index which will like make the distance maximum, that is distance between them the maximum one. So that is what the question states. Similarly, in this second question also, if we take 10 1 2 7 5, the output is for like 10. If we the first curve is placed at stall 0, that is 10, and the second curve can be placed at 1, as the difference is 10, that is 9, there is 9 difference. And also we can place the third curve at, that is 7, right? 1 7 and 1 is 6, I think 6 is the difference. And yeah, that is the case. There is 1 2 and 3, we have placed the three curves. So this is the question states. And as there's what we have to return is the minimum possible, that is minimum distance between the curves. So here the third curve can be placed at stall 4. So okay, we have to, which is the largest among the possible ways. Okay, now what would be our approach? For example, so they had given there is 3, output is 3. Okay, this is the question, right? We have to calculate the number of the minimum distance. So what we will do is, first we will place cover this index and check. We will take, that is we will run another loop, we will run another loop, that is, and we will check whether this difference between them is maximum possible. And if they're like, here the difference between them is 1, and similarly for this the distance between them is 3, for this the distance between them is, that is 7, for this the distance between them is 8, right? What we have to do is, we have to calculate such index such that it should be occurring in the maximum cases, and it should be also below the limit. So if we take 8 as a limit, we cannot place 3 curves. Similarly for 7 as the limit, we cannot place 3 curves. So here 3 is the ideal case which we can place the curves. That is the maximum distance, that is maximum possible distance we can place the curves. So let me say about the optimal one. Okay, let us take this test case itself, that is 10 1 2 7 5. Let me discuss. 10 1 2 7 5. In this question, my approach is, first we will do, what we will do is, we will sort this, we will sort the given manner as they are given. We have, as the question states, we have to calculate the maximum possible distance. They are not given like we have to put the cost at this index, this particular index. That question is not asked like that. So we will do it by sorting, that is 1 2, then 5, and then 7, and then after sorting what we'll do is, so we will apply binary search here. I will show you how we can apply binary search in this question. Okay, we will take the low index as 1. Why low index as 1? So because we should do a jump of one index. Without doing that is the minimum. We cannot do zero jumps, or we cannot do minus one jumps. We can do one jumps. So that is the minimum possible case, and we will take the higher bound, that is right, as that is rightmost index and leftmost index. The subtraction between them, that is the difference between them. Here that is 9. Okay. Left and right we have calculated, and we will calculate the mid. That is 9 plus 1, that is 9 plus 1, 10, 10 by 2 is 5. 5 would be the mid index, right? This is the sorted array. Now, what we'll do is we will calculate what is the mid here. 5 is the mid index. So, as the question states, 5 is the mid index. We will calculate whether taking 5 as the lower bound, 5 as the, that is distance between them, can we place all the curves by using an helper function. We will call that. So like 5 is the, taking 5 is the like maximum possible distance. We will check whether we should place the first curve first index, and we'll check. We'll run a for loop, and we'll check whether like 1 we'll check, and whether 2 minus 1 is greater than 5. No. If it is greater than or equal to 5, we'll subtract the cows count. Okay, we'll subtract cows count, and when the cows count becomes 0, then obviously it would be an answer, and it would be an answer, but there can be another answers also, so we'll check for another answers. So that is the thing. So as they are given 1 2 5 7 10, 5, let me check. 1 2 is not possible. Here cows will be, one cow will be placed right here, and we can 1 minus 5, that is 4. That cannot be possible. 1 7 minus 1 here possible, but 7 minus 10, that cannot be possible. So we will, so this is not an answer. 5 is not an answer, so we have to check below this. So right now, right will become mid minus 1, that is 5 minus 1, that is 4, and low will be 1 itself. And now 4 plus 1 by 5, that is 2, 2.5. So we will take mid as 2. Now, if we take mid as 2, so 1 here, 2 minus 1 is 1. It cannot be possible. 2, 1 minus 5 is 4. It can be a possible answer. Here 1 cow, here 1 cow. Okay. Now 5 minus 7 cannot be possible. 5, 10 minus 5 is possible. So 2 is one of the possible answers. Here we can check 2 is one of the possible answers. We will take 2 as the thing, but as they are given maximum possible distance, we have to calculate. So we will increment the left pointer to mid plus 1. That is, in the previous case it was 1. We will calculate to mid, that is 2. 2 plus 1 is 3. Now 3 plus 4 is 7. 7 by 2 is 3.5, that is 3. Whether 3.5 is possible? Yes, it's possible. 1 minus 5 and 5 minus 10 minus 5. 5 minus 1 and 10 minus 5. It is also possible. So the maximum will obviously be 3. And now we'll increment left to mid plus 1, that is 4. 4 plus 4 by 2, that is 4 itself. We'll calculate. Yes, it's possible, and it's possible. And when the low is incremented to mid plus 1, it violates the, that is binary search condition. So it will comes out of the loop and will return the answer. So that is the approach right here. Let me code it up. Okay. What I said is, okay, they are given int sort. First what we have to do? First we have to sort the array. Is arrays dot sort. They are given stalls right here. Okay. After sorting, we have to, in the question, after sorting we have to that is assign left and right pointers. Int l would be 1. Int r would be, what would be int r? That is stalls of n minus 1 minus stalls of that is 0. After calculating the left and right index, we will calculate, so we will assign a variable that is answer to store the answer. Now we will run the binary search template, that is while left less than or equal to right. What we'll do, we'll calculate the mid element, obviously. Mid will be left plus minus L by 2. What will Why we have to do this is to reduce the time complexity error, that is time limit exceeded TLE error. And now after calculating the mid element, we'll run, that is we'll check using like helper function. Let me name it as helper. We'll pass it the stalls. We'll pass the stalls and the mid and also curves also. Let me pass n value also. Okay. We'll make a function of boolean data type, and we'll calculate this will whether this mid element satisfies all the condition. If it satisfies, we'll store it in an answer and also increment left to mid plus 1. Else, else there is nothing to do. Right to mid minus 1. Finally, after completing the loop, we have to return the answer, right? Okay. Now this is the main part. Now let me write the helper part. Public boolean helper, the static type, right? Public static boolean helper. What we have passed is stalls. We have passed stalls, and we have passed the mid element and the cows count k, and also the length of the array. In this function, what we will do is we'll take the element first element. So what we are doing in this function is, so for example, after sorting, we'll take this element as previous element, and we'll run loop from next, that is I plus 1 index. And after whenever we get the that possible condition, that is, yeah, this element would be a possible answer, we'll take that element as current, and this would be the previous, and we'll subtract it. If it is possible, then we will decrement the cows count and assign this as the previous element. That is what I am doing in this code right now. So to store that value, will this previous would be pulse of 0. Obviously, in each and every condition, we will store the first cow at the first index itself. After previous, what we'll do is we'll run a for loop. Okay, I will assign current element also, and now for loop will be for int from first index till the end of the array. What we'll do is we'll assign current as that element at that index, that is ith index, that is stance of I. After assigning current as the stance of I, we will check if current minus my previous element is greater than or equal to mid. If it is, then obviously it would be an answer, right? So decrement k minus minus. After assigning the first cow at the first index, we should also decrement the cows count right here. So k minus minus. And current minus previous, if it is greater than or equal to mid, we will decrement the k minus minus count. And what we have to do, assign the previous as the current. What I am saying is, if this is a possible condition, that is 1 and 5, after decrement the cows count, we have to uh, So this would be the next element which the difference should be. So we will make this element as a previous element. So that is what I am doing. After doing that, we'll check whether if during an iteration if the k is equal to 0, then obviously it is one of the condition, it is one of the possible cases where we can place the curve. So we will return true, else we have written false. So I think everything in this code is right. Let me run. If there are any errors, we'll check. Yeah, it's running correctly. Let me submit. I think no error should be there. Please present result. Yeah, it's running. So this is the answer. You can take the screenshot right here. Okay, thank you guys.